Be aware of so much is this new roadmap in the middle of the stack. Oops, sorry, let's get back here. In the middle of the stack here, this will be a core architecture where we've shrunk the TDP right down, and this year we deliver that, in fact, 7 watts. We will actually even deliver below that. This will bring the core performance experience, the legacy performance experience that everyone knows and loves, down into fanless designs. By fanless designs, think of that as anything you see in this room, we will be able to run the core architecture in the next several years. Even this year, we've shown already a fanless-based design running the core architecture. I was in Taiwan the first time we presented this to all the ODMs and the OEMs, the people ultimately building all those designs, and it was a fascinating week that we had there because we saw for the first time the lights went on when they saw the last 30 years of designing PCs and notebooks was all around you had to put the microprocessor underneath the keyboard. The design constraint was always that. You had to put the microprocessor underneath the keyboard. As soon as we showed this roadmap and the ability to actually shrink these TDPs right down, the thermals that you can run at, for the first time, they could see we could immediately take that processor and put it behind the screen. And suddenly the design doors blew off. What you can do now with the Intel architecture by moving the processor from under the keyboard to behind the screen suddenly just blew apart on what you could innovate. And that's why you're starting to see around this room these very different form factors that we've seen for the last 20 years or so. You're going to hear a lot more about this, what's called the Y-Series roadmap. This is the Y-Series roadmap. You're going to hear a lot more about that from us through this year and into next year with Haswell. We did shift the core roadmap down to 70 watt, ultimately to open up the whole Ultrabook bow wave. And by bow wave, what we mean is that Ultrabook in itself is a category that we're driving in itself. At the same point, Ultrabook is having this waterfall effect of features right across the industry in terms of the thickness of the devices, the functionalities that we're building into notebooks and detachable systems. We refer to it as the Ultrabook effect. Everything suddenly went thin in the industry, and that was the Ultrabook effect. You know, it was shrinking hard drives, it was taking 3 millimeters off a screen, it was taking from cylindrical batteries to prismatic batteries. There's about 10 things that we did that shifted it from 1.25 inches down to now we're seeing sub 10 millimeter Ultrabooks. And that effect, as you start to get the whole industry around that, is now waterfalling into Ultrabook and beyond Ultrabook. This is a good thing. In 2013, last year, we ended up with 140 designs getting built around the 3rd generation core architecture. Going to this year, of course, we have the 4th generation core, which is the Haswell product, or codenamed the Haswell product. And I'm talking a little bit about the Haswell technology. So when we first announced Ultrabook in 2011, at that point, we were defining a vision for this category of products, but it wouldn't be until this year that we first had a microprocessor that was purpose-built for Ultrabook. Everything prior was already designed and in motion. So this one is the first, and there's a bunch of features we've built into this. You're well aware of the dramatic adoption of touch through all of these different devices. This year you'll see voice built into the system, that you can manage the whole device through your voice. Gesture. We've just been investing in camera companies, 3D camera companies, and building in 3D cameras, so you no longer ever have to log into your device again. When you come up in front of the device, it sees your face not as a picture, but as a 3D topographic map, and it will actually authenticate you and obviously bring you into the device. One example. You will see this year a lot of data on the performance of Haswell. I think what's really exciting about Haswell, though, is this is something where you're talking like 14 hours battery life, like a day and a half, potentially 2 days for a student in school of battery life. So awesome value proposition for what consumers really need. On the security side, I've talked about identity protection this morning. You've probably heard a little bit about anti-theft. We're doing a lot of work, as you're well aware, of our acquisition of McAfee to integrate a number of those features into the silicon, and we start to see that with Haswell. One of the interesting areas in Haswell is there's a number of sensors we're building into the system. Typical sensors, gyroscopes, accelerometers, etc., proximity sensors. But we're also putting NFC into the Haswell architecture. This is near field communications. And some really interesting usage models. I mean, how many times have you been on your phone, you've found a website that you're really interested in going a lot deeper in, but frankly on the phone, the experience is, it's really hard to navigate around it. Well, with your phone, you can basically just tap on your device, right? And through NFC, it will go and get the site and bring it up onto the full screen. Just a basic example of NFC use. There's a number of payment models we're using. Today, when you go online, Amazon or any site where you would buy something online, you've got to fill out all the form every time, right? Amazon's getting a little bit better on it, but with Haswell, with NFC built in, again, it'll authenticate you, it'll know who you are, you'll get your phone, you'll tap on the device like that, and the purchase will be done. It'll authenticate between the phone, yourself, and the device, and see you into the device. Okay, I wanted to spend a little more time though on the bottom right. It talks about convertibles and detachables. We've been doing a lot of research in all the markets around the world to really understand how people are thinking about this convergence, if you will, of the tablet era, right, and the detachable and convertible era. This is some research we've done. We gave a bunch of consumers 4 devices. We gave them a tablet, we gave them an Ultrabook without touch. So just think of like a clamshell Ultrabook, no touch. We gave them the same device, Ultrabook, but with touch. And then we gave them a detachable convertible, meaning you can rip the screen off and it could be a tablet in 1 second, you put the screen back and it's a it's a more clamshell oriented device. Did this in 4 countries, both developed and developing markets. And it's really interesting. You can see the pie chart here in terms of how people responded to this. Firstly, 75% of people would want to have a touch-enabled Ultrabook capability. And of that 75%, 44% would want that Ultrabook to be detachable or convertible, if you will, meaning it's a tablet 1 second and a clamshell the next. And we've done some more studies on this to understand if you introduce into a market a detachable technology, or a detachable form factor, I should say, in a market that has tablets and has laptops and has Ultrabooks, what happens to the consumer preference mindset? How do they think about it? Do they buy more of one or the other? Well, what we found was that as you introduce that convertible, detachable type of design, the desire for the laptop Ultrabook category increases, and the desire for pure slates decreases, meaning that people are placing more value in a device that is effectively 2-in-1 than one or the other. So I can tell you right now in Taiwan, it's fascinating to see just this craze that's going on in developing, in fact, from 10-inch designs right through to 15-inch designs, all these different form factors of detachable convertibles. There's some around the room here that you can play around with later, but mark my words, there's just a lot more coming with Haswell. One of the things with convertibles and detachables, of course, is if it is truly going to be a tablet at some point, the benchmark, of course, is the common tablets today, whether it's Apple or Samsung or whoever else. That's what people are thinking. With Haswell, they can shrink these designs down in terms of the Z-height thickness and truly get, when you rip that screen off, it truly feels like the tablet that we're used to in terms of the look and feel. Okay. I wanted to give some insight also into fixed computing, particularly all-in-ones. This is an area where, despite all of the noise and action going on in the mobile world, it's amazing the growth of the all-in-one business. This is actually last year for us a 30+% growing business. This is an extremely fast growing business, the all-in-one business. And the reason for that is it's not just a big flat screen that is also a computer, but more particularly what they're working on with the form factor. Historically, the all-in-one has been a one-to-one device. I'm the user, I come up to the device, I use the application, and I leave the device. What we're working on now is multi-user single function. You're starting to see some of these come to market where the device 1 minute is what it was, in other words, what we just said it was. The one person comes up, they're just playing around with the computer as they would always play around, whatever that is they're doing, online, photographs, whatever. But then the next minute, the child can take that whole screen, right, and put it in an easel mode rather than just a more PC mode, and it becomes this artwork easel type of device. And the device is essentially evolving relative to the user's nature of use of what it is they want to do with the device. And this is, again, just really getting started, but you can see some big names here already starting to play with us on the all-in-one adaptive ecosystem. I wanted to finish with a real key effort inside of Intel that's going on right now. We're building all of this process and performance capability to the microprocessor. What do we see as the things that are really drawing down and driving the need for all of this performance? I mentioned earlier about touch and the ramp of touch, etc. But we have been doing a lot of work with voice and gesture. But I can give you just some, I think I've got on the next foil here. I can quote you the data. We've done a study on giving voice control to the PC, to the Ultrabook, to the all-in-one type device, and trying to understand how people react to the concept of controlling this device through their voice. And we gave, I think it's to 60 consumers, we gave it for 2 months, and then we got a whole bunch of feedback. And, you know, I think people have very mixed feelings about some of these new perceptual interfaces with compute devices. After 2 months, these consumers, 65% of the times, were using voice multiple times a day and controlling their system. So, to do that, to get the quality of voice right, requires a lot of processing power. So, hence we're interested. And hence we're really trying to optimize how we can truly make voice a very natural interface to the compute device and not an unnatural, which has historically been the case and my voice has never taken off. That's just one example. It is not just about it's the mouse or touch or voice or gesture. All of these are coming together, and you will begin to gesture, voice, touch the device all at the same time. And this is really increasingly interesting when you think what I just talked about with the all-in-one and a multi-user construct. We think of the all-in-one or any of these devices, they're still, in many respects, as one person in front of the device at once. In the all-in-one, in the lounge or the kitchen, the concept of a child in front of it working their homework while a mother comes past and speaks to that device and it answers the mother together. Right? These are the multi-user constructs and multi-gestural, multi-perceptual things working together at once that creates amazing new experiences and all new breakthrough experiences on Intel. So hopefully that gives you a little insight into what we're working on. I think that's pretty much what I had to talk through. Happy to take, are we doing some Q&A now, or happy to do Q&A now? So